Hello there and welcome to today's class. For today, we'll be diving into an important topic in mathematics called matrix and determinants, right? So let's dive into matrix and determinants. First things first, we're going to be discussing about the concept of matrix before determinant. So what is matrix by definition? A matrix is simply the array of numbers in rows and column, that's all. A matrix is simply the array, or perhaps the arrangement. Array means arrangement. So a matrix is simply the array of numbers in rows and column. It is usually a case in a round bracket. It is usually encased in a round bracket. So that's like the definition for a matrix there, right? So it's important to note something, please. Note the horizontal array of number is called the row. Note number one, the horizontal array of number, that is the horizontal arrangement per se. The horizontal arrangement of number is called the row, while the vertical arrangement of number is called the column, right? That's like the very important keyword you need to note when it comes to matrix. So the horizontal array, or perhaps arrangement of number, is called the row, while the vertical arrangement of number is called the column. That's like the concept there. Having considered the definition of matrix, let's dive into an important concept there called dimension of a matrix. Dimension of a matrix. Dimension of a matrix. All right, let's dive into dimension of a matrix. Definition: the dimension of a matrix is expressed as m by, please, this is not m times n, it is m by n, right? M by n, we call it m by n, not m times n. So that's like dimension. These are to represent a dimension of a matrix. Let's define this, where m is called number of row in a matrix, where n is called number of columns, right, in a matrix. So the dimension of the matrix is represented by m by n. What's m? What's n? M is called number of row in a matrix, while n is called number of column in a matrix, right? So if I'm given a matrix, to get dimension is quite simple. Count the number of row. The number of row will be here. Simply count the number of column. The number there will be here. So let's take an example to further explain the dimension of a matrix. Example: identify the following dimension of matrix given. Identify the following dimension of the matrix given. Identify the following dimension of the matrix given. Number one, let's say I'm given the matrix A to be equal to alright, let's say I'm given number 2, matrix B to be equal to I'm given C. 4, 1, 2, 5. Alright, let's get the dimension of this matrix. Now we said when it comes to dimension of a matrix, you are actually representing it row by column. So your first task is to start with number of row. And we said row, this is m. So it means that my dimension here will be something of this nature. This is times number of row will be here, number of column will be here. So it means that we said m is what? Number of row. So row, we said row is simply what? Horizontal arrangement of numbers. So it can be like this. This is 1. So this is what? This is 1. This is row 1. This is what? Row 2. So I have what? 2 rows. That becomes 2. Next up, we said n is what? The number of column in a matrix, and the vertical, we said the vertical arrangement of number is called what? The column. So it means that if I'm going this way, this is column 1, this is column 2. So I'm having 2 columns. So this is a 2 by 2 dimension. So this matrix here is a what? A 2 by 2 matrix. Let's get this one done. It's like quite simple. Count number of row first. 1, 2, 3. I have 3 row multiplied by 3 by number of column. 1, 2. I have 2 columns. So this matrix then is a what? Is a 3 by 2 matrix. Let's get this one done here. For this one here, I will have number of row first. 1, 2, 3. I have 3 by number of column. 1, 2, 3, 4. So this is a 3 by 4 matrix. These are to find the dimension of a given matrix. I want to understand the definition of matrix and the arrangement of number when it comes to matrix, row, column, right? And I haven't discussed the dimension of matrix. Let's dive into the algebra of a matrix. By algebra of a matrix, what do we mean? We mean how to add a matrix, how to subtract a matrix, and how to multiply, even how to divide a matrix. So let's start with the addition and subtraction of a matrix. So I have the addition and subtraction of a matrix. So how do you add a matrix? What's the condition behind adding a matrix? Put down 2 or more matrices can only add or subtract. 2 or more matrices can only add or subtract if they are of the same dimension. 2 matrices can only add or subtract if they are of the same dimension. So it means that if I'm having a matrix and another matrix, either adding or subtracting, the condition there is that what? They must be of what? Of the same dimension. And I just explained that dimension for you now. Let's say I have some matrix adding up. Let's say I have a matrix A to be equal to 2, 3, 4, 5, right? Adding up with matrix B. This matrix B is 1, 3, 1, let's say 2. Alright, from here now, first task, find, because it says, given a matrix A and B as this, find A minus B and find B minus A minus B and A minus B and A plus B. Now, here's what we're looking for. Subtraction. I'm subtracting A minus B. I'm subtracting A from B, and I'm also what? Subtracting, adding A plus B, adding the two matrices. Your first task is that ask yourself, can they add? Can they multiply? You said the condition for them to add is that they must be of the same of the same dimension. So let's check dimension for A and B. If they are the same, then you can add them and subtract them. So look up for this one. For A is what? 1, 2. That is what? The row 1, 2. I have 2 row 1, 2 column. So this is a 2 by 2 dimension. It means that this one too must be 2 by 2 dimension. If it's 2 by 2, then they can add. Let's confirm. This is 1, 2. Row is 2, 1, 2. Column is 2. So this is what? A 2 by 2 dimension. So the first one is 2 by 2. The second one is what? 2 by 2. It means what? They can add up. So when they're adding, how do you add them? So to find A, let's have A plus B. A plus B simply means I have a matrix A. That's 2, 3, 4, and 5. This one here, adding up with the second matrix here. 1, 1, 3, and what then? And 2. How do you add them? The task is simple. Add the corresponding position. Or when it comes to the addition, you add what? Corresponding position. When it comes to subtraction, you subtract the corresponding position. That's all. So let's add this one up. My adding up becomes 2 corresponding position. 2 plus 1. This is 2 plus 1. That will give 3. Next up, 4 plus 3. That will give 7. 3 plus 1. That will give 4. 5 plus 2. That will give 7. So I have your task to add corresponding position. This and this are in the same position. Add them up. I have this. This and this, the same position. Add them up. I have this. This one and this, the same position. Add them up. You have this one here. This and this, the same position. Add them up. You have this. This is like the addition of this matrix here. Let's get the subtraction. That becomes A minus B. To get A minus B, what do you do? You have the first one, A, as 2, 3, 4, 5. I have this. Minusing the other one, 1, 1, 3, 2. Right? So for these two matrices to subtract, obviously you said the condition is that they must be of the same dimension, which is 2 by 2, 2 by 2, which is good. Next start the same. We should what? Subtract the corresponding position. 2 minus 1 will give 1. 4 minus 3 will give 1. 3 minus 1 will give 2. 5 minus 2 will give 3. So I have this as my answer after looking for the addition and subtraction of the matrix. So let me give you a question. I'll give you a matrix A and B, and I'll ask you to add them up. If they can add, let me know. So if I'm adding a matrix A as let's say I have 3, 2, 4, 5, 6, 7, and the matrix B to be equal to 3, 3, 4, 2. Now find A plus B. Now look up. Find A plus B here. You should your first task now is to get the dimension. This is a what? This is a 2 by 3 dimension. This is a what? A 2 by 2. So 2 by 3 and 2 by 3 and 2 by 3 and 2 by 2, they are not the same, so they can't add. So they are giving this one a jump, like add them up. There's no answer to this one, please. No answer. 0 becomes the answer here. 0 becomes the answer here, please. So your task is to check, are they of the same dimension before you add or subtract them. Now, when you have confirmed if they are of the same dimension, then you add corresponding position as we did here, or perhaps subtract corresponding position. Alright, I will consider the addition and subtraction of the matrix. Let's dive into the multiplication of the matrix. How do you multiply matrix? Let's discuss that shortly. Welcome back. Let's try to solve this typical problem before we dive into multiplication of a matrix. So let's say I'm given this question here. I'm given a matrix A to be this, matrix B to be this and C to be this. I'm told to find what they find 2A plus B. Question B says find 2A plus 3B. Question C says A minus A plus 2C. So how do you solve this? Right? So first task, solution. My first task, we said the first condition here is to check if they are of what the same dimension. Of course, this is 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2, right? 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. First task, these are similar, right? But check first, check the dimension. This is what 1 2, a 2 by 1 2 3, a 2 by 3. This one 2 is what 2 by 1 2 3 by 3, 2 1 2 1 2 3. They are all what 2 by 3, so they can add and subtract because they are of the same dimension. That's the first task there. Next task now is that I will check if they are the same dimension. Next task now is that I'll move on here to start solving the questions, right? So I'm having A. Question A says 2A plus B. First task, I'm having 2 into what's matrix A is this one here. That's 1 2 4 1 and 2 1 and here plus matrix B. What's matrix B here? That's this one here into minus 1 2 1 4 minus 1 and 3. So I have this here. I have this. So at this point here, use this 2 here to multiply everything. 2 times 1, I'll have 2. 2 times 4 becomes 8. 2 times 2 becomes 4. Please I work on this. 2 times 2 becomes 4. 2 times 1 becomes 1. Sorry, 2. 2 times 1 becomes 2. I'm done with this. Plus, pick out this down. I'll have minus 1, 1, minus 1, 3, 4, and 2. Let's add them up. Let's add this one up to get our final answer for A. From here now, look up. We said add what? Corresponding positions, right? So 2 plus minus 1 will give 1, right? 2 plus minus 1. Plus minus is minus. 2 minus 1 is 1. 8 plus 1 becomes 9. 4 plus minus 1 becomes plus minus is minus. 4 minus 1 is what? 3. I have this. Next up, take the corresponding position of the next one. 4 plus 2. That's 6. 2 plus 4. That's 6. And 2 plus 3. That's 5. So I have this one as my answer for question A. So this is how to add this one here. Let's do question B. Question B says 2A plus 3B minus C. Let's try to solve this one here. It means that matrix A, I'll multiply matrix A by 2. Then I'll multiply B, matrix B by 3 all through. Then minus it from C. Let's try to solve this one together. For this one here, alright, I'll do B. You do C for me, right? You do C for me. Do C for me. I'll leave your answer in the comment section below. I'll reply if you're correct. You do C. So let's try to do B and use the idea to do C. For B, first task, I'm having 2 multiplied by matrix A is what there. I'm having 1 2 4 1 and 2 1 as matrix A plus 3 into matrix B is what there. Minus 1 2 1 4 minus 1 and 3. I'm done with matrix this one here. Minus 1 C. C is given to me 1 1 1 all true. 1 1. I have minus, this is C. For C, I have this one here. Plug it here. At this point here, let's try to solve this one here. Use 2 to multiply through. For this one here, I just did something of this nature here. So I had this one. This one is what is here. So what I had is this. So just put in this one. That becomes 2 4 8 2 4 and 2. I'm done with the 2 multiply this is all this here. Next up plus plus into use 3 to multiply through. 3 times minus 1 is minus 3. 3 times 1 is obviously 3. 3 times minus 1 is what? Minus 3. 3 times 2 we give 6. Next up, 3 times 4 we give 12. And 3 times 3 we give 9, obviously. Next up, minus into, this is 1 1 1 1 1, right? 1 1 and 1 1. Have this. Let's get this done, please. First task, I can't just pick, I can't say 2 plus minus 3 minus 1. No, start with the plus first. Pick these 2, solve this one first. The answer you get, then your answer subtract from this last one here. That's how you do it. Don't pick them together. So pick this one first. So if I add them up here, I'll have, instead for the addition, add what? Corresponding position. Either addition or subtraction. The first task is what? Add corresponding position. So 2 plus minus 3 will give minus 1. 8 plus 3, that will give 11. 4 plus minus 3, that will give what? 1. Next up, 4 plus 6 will give 10. Next up, 2 plus 12 will give 14. Finally, 2 plus 9 will give 11. Right? I'm done with these 2. Next up, I'm left with what? Minus into 1 1 1 1 1 1. Let's get this done, please. For this one here, your task is the same thing. This is a minus sign and they are the same dimension, no problem. We said when it comes to subtraction, just what? Subtract what? Their corresponding positions. So here, minus 1, that will give, observe, this is minus 1. Next up, minus 1 will give minus 2. 11 minus 1 will give 10. 1 minus 1 will give 0. 10 minus 1 will give 9. 14 minus 1 will give 13. 11 minus 1 will give 10. Right? 11 minus 1 will give 10. So this might be answer to question B. So do question C and put your answer in the comment section below. Let's now dive into multiplication of a matrix. How to multiply matrix? How do you multiply matrix? What's the condition behind multiplication of matrix? Let's dive into multiplication of a matrix. Alright, let's dive into multiplication of a matrix, as you can see. Alright, here's the condition. Put down 2 matrices can only multiply. 2 matrices can only multiply if the number of column of the first bracket, or perhaps of the first matrix, is equal to number of row of the other matrix. I'm saying that 2 matrices can only multiply if the number of column of the first matrix is equal to the number of row of the second matrix. So when we're given 2 matrices to multiply, the first task is to get the dimension of the first one and the second one. When you are done, check the number of column of the first one. If it's equal to number of column of the other one, if they are the same number, hence they can multiply. That's like the condition behind multiplication of a matrix. Let's take an example to further explain this idea. Let's have having a matrix, in this case matrix A. A to be, let's say 2 3 4 2 3 4 5. Matrix B to be equal to 2 3 4. Right? Matrix A and B. Now, the question says find A times B. Find A times B. It means multiply matrix A and B. The first task is that get the dimension of the 2. For this one, it is a 2 by 2, right? 2 by 2 dimension. A 2 by 2 dimension. For this one is what? This is a 1 2 3. This is a 3 by 2, right? 3 by 1 perhaps. Perhaps let me add some value here. 1 1 this way. Yes, let's take this. This is what? 1 2 2 by 1 2 3. 2 by 3. Let's take this one too. This because what? This is one. Sorry, column first, row first. 1, 2, 3. This is 3 by column is 1. So get the first task when it comes to multiplication of a matrix. Get a dimension. This is the dimension for this. Dimension for this. We said the condition is that the number of the number of column of the first bracket, which is this. This is row column. This is column of the first bracket. We said number of column of the first bracket must be equal to number of row. So this is row of the second matrix. Hence, they can multiply. Look up now. My first matrix said this is row column. Row column. We said the condition for them to multiply is that the number of column of the first bracket, which is 3 here, must be equal to number of row of the second matrix, which is 1, 3 here. So there are 3, 3. Hence, they can what? They can multiply. That's the condition. Please watch out for this stuff, please. And when they multiply finish, our answer must be in what? A 2 by 1 dimension. That's the condition again. So I will confirm that this is a 3 and this is a 3, 3. That's the condition. 3, 3 abi. I will consider that the next dimension is 2 and 1. It means that our answer, the dimension of our answer will be what? A 2 by 1 dimension. Right? So let's try to solve this one here. Let's multiply this. So if I multiply matrix A and B together, how do you work with that? So I'll have matrix A as 2, 3, 4, 5, 1, 1. This one here, multiplying with what? 2, 3, 4. How do you solve this? First task is to confirm how much we did here. When you are done confirming, here's the idea when it comes to multiplying matrix. We deal with what? Row column multiplication. Row column. Row then column multiplication. Here's the idea. Note that row column multiplication. Let's start with this. Look up. Now this one here. This is 2 times 2. That will give 4. Start with this one here. Row column, right? This is row, then column multiplication. 2 start with this. I'll have 2 times 2 separately plus 4 times 3. This is 3 here. Observe. Plus 1 times 4. I'm done with this. Next one, move on to the next one here. This one here. I'm done with this, right? Move on to the next one here. For this one here, I'll have 3 times 2. That becomes 3 times 2 plus 5 times 3, right? So plus 5 times 3 plus 1 times 4. 1 times 4. From here, let's get our value correctly. So it means that 4 times 2 times 2 will give 4 plus 4 times this is 12 plus this is 4, 6 plus 15 plus 4. Right? At this point, they add them up. If I had my upper one here, that's 20, right? 4 plus 4 is 8. 8 plus 12 there, that's 20. Add this one here, this one, add them up here. This is 30. No, sorry, yes, 30. This is 10, 25, sorry, 25, yeah. Observe that my answer here is what? 20 and 25, right? I'm having 20 and 25 here as my answer. So it was what? Let's get the dimension for this one. This is what? Row 1, 2, 2 by 1, column is 1. So we said at the end, our answer will what? Make a 2 by 1 dimension, which is true. Here. This is how to multiply a given matrix, right? This is like the idea behind how to multiply a matrix. Check if the number of column of the first matrix is equal to number of row of the second matrix. When you are done with that, then we do a row column multiplication, as in this case, then we are there, right? So let's take few more examples on this, and so let's try to work on this sample problem 2 under multiplication of a matrix. So how you solve this? First task, confirm your dimension. For this one here, this is the what? 1, 2. Row is 2 by 1, 2, 3. This is 2 by 3. For this one here is what? 1, 2, 3. This is 3 by 1, 2, 3 by 2. The condition says that the number of column of the first matrix, which is 3 here, must be equal to number of row of the second matrix. Row is what? This. So this is 3, 3. This is true, right? So they can multiply. That's the condition. Now my answer must be what? A 2 by 2 dimension. A 2 by 2 dimension. That's the idea. So after taking out your condition, the remaining dimension will give you, the remaining number will give you what? The answer dimension. So let's try to solve this one here. First task, start with what? Your row column what? Multiplication. Start with 1 times this 3. Next up, plus this is 2 times this 1. Next up, 1 times 4. I'm done with this, right? Take out the same one here again. I'll have 1 times this 3 plus 2 times 6, right? Plus 1 times 2. I'm done with this one. I'm done with this. Next up, take out this 2 with this one. Row column, right? So I'll have 2 times 3. 3 plus 2 times 1, right? Plus 1 times 4. I have this. Next up, I'm done with this one. Row column. Take out this row and this column together. That's 2. This 2 times this 1 plus 2 times 6, and finally 1 times 2. Right? Now let's try to simplify this one better. So at this point here, 3 times 3, 1 times 3 is 3, plus 2 plus 4, 6 plus 2 plus 4. This is for this one here. For this one becomes 3, observe, 3 plus 12 plus 2, 2 plus 12 plus 2, right? Add them up here. Add them up here. This is 6 plus this is 10. This is 10. 4 plus 8, 6 plus 4 is 10, but this is 12. This for this one. For this one becomes this is 12. This is 14. 14 plus that's 17. This is 4 plus this 2 plus 2 is 4. 4 plus 14. That's 16. I have this, right? Right, I have this. So this is like the answer. Now let's confirm something. Those dimension for this is a what? A 2 by 2 dimension. So I have a 2 by 2 dimension. So this has to solve multiplication or perhaps has to work on multiplication of a matrix. So let's dive into one concept called determinant, right? Let's discuss determinant. What's a determinant?